All right, good morning, gentlemen. So this is part two. So by now you would have done the is it a right triangle lesson. So that was lesson 5. You had a worksheet to complete, and this is moving forward. I would say that your goal for today is to have this note done. And if you could, you can work on the worksheet, but that's not the goal. Just to be finished this note and understand how we went along through this. If you get ahead, perfect, great, awesome. The teacher has that worksheet for you to do so. Okay, but we'll get started on this. So Pythagorean theorem word problems, and what you're going to notice with these questions is that it's not just about finding the length of a side. It might incorporate other problems or other goals for you to complete. Okay, they all involve triangles, obviously. So if you think about it, it could be about the height of something, a real world situation, it could be the area of a triangle, but it still requires you to find at least one of the sides in doing so. And so that's what we're going to use the Pythagorean theorem for. So I want you to be able to collect and organize information in your word problem to make sure that you set it up properly. Okay, and I want you to be able to visualize what the word problem looks like to develop an understanding of what's being asked. Okay, we approach any type of word problem the same way. So we collect our information, organize it, then look for key terms to find out what the question is asking us to find out. So I've set it up in such a way where we can fill in the blanks, okay, as we go along. So let's read it out. Fred and Susan are putting in a new hand railing for their staircase that goes directly from the second floor to the first without any turns. So it goes straight up and down. If you can visualize that in your head, that'll be a big help. If they know the distance from the first floor directly to the second floor where the railing starts is 4 meters and the staircase covers a horizontal distance of 6 meters, then how long should Fred and Susan cut the piece of wood for the railing? So what do we know? Okay, one thing we do know is we know the height. Okay, the height is 4 meters. Okay, and we know that the horizontal distance of the entire staircase is 6 meters. So what that means is that you're moving left to right on the staircase a total of 6 meters by the time you get to the top. So what facts could be helpful? Well, we know that it's a staircase. We know that a new hand railing for the staircase that goes directly from the second floor to the first without any turns. They need to know how far they're going or how big they're going to cut that. Okay. What they want to find out is how long should Fred and Susan cut the piece of wood for the railing. Okay. So what facts could be helpful? Well, a staircase forms a triangle with the roof and the floor. And can I draw a picture? Absolutely. Okay. So if this is your top of the stairs, you have a staircase that goes all the way down. Okay, however creative or perfect you want it to be, that's up to you. And within the staircase, okay, it has a horizontal distance across the bottom, so that's the floor, and it has a height. Okay, and so what they're doing is they're saying that the height, the top of this railing up here, we'll draw another line here, the top of this railing here is what they want to find out. So look at that, there is your right angle triangle. Okay, so we know that the height is 4 meters. We know that the horizontal distance is 6 meters. But we don't know how big this is. And we know that directly across from that 90 degrees, so it's our C value. Okay, so we can definitely draw a picture. what am I trying to find out? The length of the railing, or C, the hypotenuse. Okay, so set up our equation. A squared plus B squared equals C squared. We have an A and a B as 4 and 6. So 4 plus 6, both squared, equals C squared. So 16 plus 36 equals C squared. Okay, add them together, we get 52 equals C squared. Okay, so we think to ourselves, C times C, or a number times itself, gives us 52. To find out that number, we have to square root, and we find out what C is. So we take our calculator, and we'll go 52 square root gives us 7.21. And for most questions like this, I'll get you guys to keep it to just 2 decimal places. So we have 7 decimal. One thing that doesn't stick for me is that decimal place. 2.1 meters. Okay? And obviously, because it's a word problem, we're going to finish with a concluding statement. So therefore, we'll just check those names again. Fred and Susan. Therefore, Fred and Susan will have to cut a piece of wood for the railing that is 7.21 meters long. Okay? Done. Alright, so here's our final question, our finished product. Okay? We find out, or we look at what we know. We look at what we know. Okay? What facts could be helpful that make it look like a triangle? Can we draw a picture? What are you trying to find out? So make that connection between what's the hypotenuse, okay, or how these sides relate to a Pythagorean theorem or a triangle. And then finally, do our work and finish with a concluding statement. Okay, we'll try another one. So we'll scroll down. This one. All right. So one end of a 15-meter guide wire is attached to the top of a telephone pole, and the other end is stuck in the ground 10 meters away from the base of the pole. How high is the telephone pole? So what do we know? 15-meter guide wire. Okay, and the guide wire that's stuck in the ground, okay, is 10 meters away from the pole. So guide wire in ground is 10 meters away from the pole. Okay, and if you're not sure what a guide wire is, it's just something that sort of stabilizes really tall objects. It keeps them from going too far to one side, and usually have a few guide wires going to either side of it. Okay, so what facts could be helpful? Well, this creates a triangle. And because the pole is straight up and down and perpendicular with the ground, okay, it ends up making a right angle triangle. So this creates a triangle, right angle. Oops. Right angle. Can I draw a picture? Absolutely. Okay, so depending on how artistic you want to be, we take our telephone pole like this. Okay, and we'll go back to pens. Take a telephone pole like that. A guide wire will usually go down. Maybe I can give you like a dotted line here. I'll choose this one here. Okay, this guide wire will go from the very top of the pole right down to the ground. Okay, I'll make that black. Shape effects, shape outline, dashes. Okay, there's your guide wire. Okay, but what it doesn't tell you really is that there's a base to it. Okay, and in this case, the ground acts as a base. Okay, so if this is the ground, this is the grass that the wire's attached to. Okay, this completes your triangle. So you have a right angle right here. Okay, now we can start labeling the triangle. So it says at one end a 15-meter guide wire. So if this is the guide wire, this is 15 meters. And it says the guide wire down here is 10 meters away from the pole. So 10 meters away. Okay, so what we have to find out is how high the telephone pole is. Okay, so as we're filling this in, what am I trying to find out? The height of the telephone pole, i.e. a side length. Okay, so not quite using the exact formula a squared plus b squared equals c squared, so we'll have to do a little bit of rearranging. We'll set it up either way. A squared plus b squared equals c squared. Okay, and what we're going to do is label these here b, a, c. And if we're trying to find a, we want to get a by itself. Okay, we want to finish the question off with a equals something, which means that we have to move this guy over here. And whenever you're working with addition or subtraction and you want to move a variable across the equal sign, the sign in front of it actually changes. So you switch the sign. So this ends up becoming c squared minus b squared. And all we're left with on this side is a squared. So we'll fill in the information we know. So a squared equals 15 squared minus 10 squared. Okay, we'll put brackets around that. Okay, just quickly. Okay, 225 minus 100 equals 125 for a squared. Okay, to find out what a is, we have to square root. Okay, we end up with a equals, lost my calculator. Okay, 125, take the square root. So we end up with, again, two decimal places, 11.18. A equals 11 decimal, decimal 18 meters. Okay, finish with the concluding statement. Therefore, the height of the telephone pole is 11.18 meters. Okay? Alright. So we're on page 2. We have one more for this page here. Dig went for a jog around his neighborhood. He traveled from the end of his driveway 500 meters east, then turned north and traveled until he was a direct distance of 900 meters from his home. If Dig was to do a complete lap around the block of his neighborhood, how far would he have traveled? So this immediately is a question where it doesn't necessarily just involve the the side length of a triangle. In fact, you're going to have to do a little bit of extra calculating with this one. So what do we know? 500 meters east, then north. Okay. Eventually went around the block. Okay. What facts should be helpful or could be helpful? Okay. Distance. Okay. 900 meters is diagonally away from home. Okay, so when we see that, okay, and the fact that this guy has gone east and then north, he's turned at 90 degrees, and then he ended up being 900 meters directly from home. So this is important here. So 900 meters from home directly. Okay, so we're going to draw a little picture. Okay, say that this is him. Okay, and this is his house. Okay, and he went this way, and he went this way for 500 meters. So this is east. Okay, all of a sudden he travels north for a certain distance, and we find out that up here he is 900 meters away. Okay, so look at that, we formed a triangle. But the question, what it's really asking is that if this guy completed an entire lap around his block, he would have went back this way, and then back down, and ended off back at his house. Okay, so we went all the way around. Okay, so what we're seeing is this triangle here can help us with our answer. Okay, so what we're going to do is we're going to label the sides of our triangle. So on this side, okay, we're going to label this as C. On this side, we'll say this is A and say this is B. Okay, so what we're eventually going to find is that we're going to take this length here and this length here, okay, and we're going to add it to this length, okay, which is also the same as B, and add it to this length, which is also the same as A. Add them all together, we get the full distance that this guy has traveled. Okay, so we'll write out our equation. A squared plus B squared equals C squared. A, 900 meters, or 900 squared, plus B squared is, oh, sorry, gotta erase that. Okay, I'll take a different approach here. Okay, we want to find out what A is. Okay, so like the last question, we're going to move that B over here. So we're going to be left with A squared equals C squared minus B squared. Okay, remember that sign in front of the B switches. Okay, so A squared equals 900 squared minus 500 squared. A squared equals, we'll just do a calculator, they're going to get big zeros here, so 900 times 900 gives us 810,000. And 500 times 500 is 250,000. Okay, so A squared equals 810 minus 250,000. So we're left with 560,000. So A squared is 560,000. To find out what A is, take the square root 560,000. Okay, so that's our number, square root, and we get 748.33. So A equals 748.33 meters. Okay, so that's the value of his trip going north. So if he's completing the entire trip around his block, okay, he's going to end up going 748 meters south as well. And he's going to be going 900 meters west as well, because he's going to end up back at home. So we're going to add our numbers together here. So we have our east and west, 500 meters plus 500 meters, plus our north and south, 748.33 plus 748.33. We get our answer. So we've got 1,000 plus 748.33 plus 748.33. 2,496.66. Okay, so that's your final answer. So therefore, Dig traveled a total of 2,496.66 meters. Okay, so this is a perfect example of a question where you're using the Pythagorean theorem to solve a much bigger problem. So finding the length of a side is only a part of the question. Okay, all right, so that's the end of the sheet that I've given you. There's also one more question here. I'm going to leave it on the screen for just a second for you guys to try if you want to. We'll come back to it and we'll talk about it when I get back. Okay. Basically, two gym classes have to share a rectangular gymnasium and decide to split it up corner to corner, forming two triangles. This suits the activity they're doing, as weird as it seems. Okay, so you got triangles that you can play in. The teacher creates a line with a piece of tape from corner to corner using the entire roll of a 30-meter tape roll. If the width of the gym is 20 meters, how big is the area that each class gets to use? So really important that you understand that you're going to have to find base times height to find area of a triangle. And since you don't have one of those, okay, you have to use the Pythagorean theorem to find out that length first. Okay, so we're going to stop there. If there's time, there's a worksheet for you guys to be working on that has to do with word problems. It's not for homework. You will have time at the start of the next class to work on it. What's important is that you just followed along with this note. You're happy with it, you understand it. And if you have any questions, you're going to email me. Okay, so that's it for this one. Good luck, and we'll see you when I get back.